Alright, section 2, oxyacetylene welding. Fundamentals of gas cutting and welding. Section 2, oxyacetylene welding. Oxyacetylene welding processes the combination of oxyacetylene gases to provide a high temperature flame. High temperature flame metals the metal face of the workpiece for the joint and cause them to flow together. A filler metal alloy is normally added, sometimes used to prevent oxidation to facilitate the metal union. The amount of heat applied with the metal is functioning of the welding tip size, speed of the travel, the welding position, the flame size determine the welding tip size, and the proper type size determine the metal thickness of the joint design. Characteristic oxyacetylene welding process include the usual dual oxygen acetylene gases stored under pressure in steel cylinders. Its ability to switch quickly to cutting process, change the welding tip of the cutting tip. The high temperature gas mixture attains at 5,800 degrees Fahrenheit. The high regulators gas control gases reduce the pressure on both the oxygen and acetylene tank. The use of the double line rubber hose and conduct the gas of the tanks of the torch metal materials to be welded together. The ability to regulate in temperature, adding adjusting gas flow. Types of welding flames. Acetylene welding flame is the most important tool. The welding equipment simply serves to maintain and control the flame. The flame must be the proper size and shape, the condition in order to operate the maximum efficiency. Three distinct types of flames are possible on adjusting the proper portions of acetylene oxygen. A neutral flame, acetylene oxygen in equal portions. Oxidation flame, excessive oxygen, and reducing flame, excessive acetylene. The neutral flame is produced with the ratio oxygen to acetylene mixture leaving the torch is almost exactly 1 to 1. The temperature of the neutral flame is an order about 5,900 degrees. Neutral flame at 5,850 degrees. Fusion welding, steel, and cast iron. Characteristics of the neutral flame. The neutral flame is obtained with approximately 1 volume of oxygen, 1 volume of acetylene as mixed in the term neutral because it is usually has no chemical effect with metal being welded. It will not oxidize the weld metal. It will not cause an increase with the carbon content of the welded metal. Neutral flame is obtained gradually, opening the oxygen valve, shorten the acetylene flame until the clearly defined inner cone is visible. For strictly neutral flame, no whitish streams or feathers should be present at the end of the cone. Neutral flame is one of the most welding operations preheating during the cutting operations. The welding steel of the neutral flame, the molten metal puddle is quite clear. The metal flows easily without boiling or foaming and sparking. There are two clearly defined zones in the neutral flame. The inner zone consisting of a luminous cone with the bluish and white. The inner cone with the acetylene and the oxygen combined, surrounding this light blue flame envelope with sheath. The natural flame is obtained starting the excessive acetylene flame, in which there is a flame extension of the inner cone with the flow of the acetylene, decreased flow of oxygen, increased with the feather, which will tend to disappear. The neutral flame begins with the feather and disappears. Alright, your bluish white, light blue, and purple flame torch tip. The tip inner liner is hottest part of the flame, approximately 5,850 degrees and Fahrenheit. At the end of the outer shield of the envelope, the temperature drops to approximately 2,300 degrees Fahrenheit. Alright, the variation of this flame permits of some of the temperature control of when making a weld. The position of the flame of the molten puddle can be changed with the heated control in this manner. The neutral flame is commonly used with the welding of mild steel, stainless steel, cast iron, copper, and aluminum. Carbonizing the reducing flame of full oxygen supplied and a neutral flame is reduced, resulting in flame with the carbonizing reducing flame and rich acetylene. Reducing flame can be recognized with the acetylene feather in which they between the inner cone and the outer envelope. The outer flame envelopes is longer than the neutral flame and is usually much brighter and greater. This is a carbonizing flame is excessive acetylene within the oxygen, 5,700 degrees Fahrenheit, used with a hard-facing welding white metal. Characters reducing carbonizing flame. An excess of acetylene creates a carbonizing flame. Reducing the carbonizing flame and obtained with a slightly less 1 volume of oxygen is mixed with 1 volume of acetylene. The flame is obtained with the first adjusting the neutral, then slowly opening the acetylene valve until the acetylene streamer or feather is at the end of the inner cone. The length of the excessive streamer indicates the degree of flame carbonization. For the most welding operation, the streamer should be more than 1/2 the length of the inner core. The carbonizing flame is characterized by the 3 flame zones: the hotter inner cone, the white cone, hot acetylene feather, the blue colored outer cone. This type of the flame is observed where the oxygen is first added with the burning of the acetylene, then the feather is adjusted, made with every small and adjusting increase amount of the oxygen of the flame. A welding feather is measured by 2x, 3x, or x being the length of the inner flame of the zone. The type of the flame burns the course of brushing sound. A temperature of approximately 5,700 degrees or 3,149 degrees Celsius at the inner cone tips. The feather is causing completely combustion with acetylene to cause excessive carbon in the flame. Bluish white, light blue, and purple. The carbonizing flame may add carbon to the welded metal, will tend to remove the oxygen iron oxide which may be present. In fact, the cause of the flame to be known as the reducing flame. The iron steel is produced very hard, brittle substance known as iron carbide. The chemical change makes it metal unit unfit to make applications in which weld may need to be bent or stretched. The metals intend to absorb carbon and should not be welded with reducing flame. Producing flame is typically used with welding high carbon steel in hard-facing operation, black-handed pipe welding techniques. When used with the silver solder and soft solders operation, only intermediate outer flames are used. The important low temperature soaking heat and the parts of it being soldered. Since the flame provides with a strong reducing atmosphere in the welding zone, it is useful for those materials which are readily oxidized, like oxygen-free copper alloys. It also used with high carbon steels and cast iron and hard surfaces with high-speed steel and cement carbides. Reducing flame has approximately temperature of 5,500 degrees, which is the lowest among all three flames. Reducing flame, distinguishing carbonizing flame by the fact that the carbonizing flame contains more acetylene than reducing flame. The carbonizing flame is used in the welding, leading the carbonizing surface hardening some purposes. Reducing flame, on the other hand, is not carbonized metal rather than ensure absence of oxidation condition. Is used in welding low alloy steels, rods, and welding those of metals of non-ferrous that do not tend to absorb carbon. This flame is very well used in welding high carbon steel. Or your oxidizing flame. The oxidizing flame is the third possible flame adjustment. It occurs with the ratio oxygen and acetylene required. Neutral flame is changed with the giving excessive oxygen. Flame type is observed when the welders add more oxygen into the neutral flame. Your oxidizing flame acetylene is in excess oxygen, 6,300 degrees Fahrenheit. From the braze welding and the bronze rod, the presence of oxygen is flame creates undesirable oxidized structure, mechanical deterioration of the most metals, the usual welding copper-based alloys and zinc-based alloys and cast iron, magnetic steel, magnesium steel, etc. Alright, characteristics of the oxidizing flame. The oxidizing flame produces slightly more than one volume of the oxygen mixed with one volume of acetylene. To obtain the type of the flame, the torch should be first adjusted to the neutral flame. The flow of the oxygen is then increased until the inner cone is shortened to 1/10 of the original length, and when the flame is properly adjusted, the inner cone is pointed slightly purple, and an oxidizing flame can be recognized with a distinct hissing sound. The temperature of the flame is approximately 6,300 degrees Fahrenheit or 3,480 degrees Celsius at the inner core tip. An oxidizing flame can be recognized with a small white cone, which is shorter than much blurred than color, more pointed than a neutral flame. The outer flame envelope is much shorter and tends to fan out of the end of the other hand, but the neutral carbonizing envelopes tend to come to sharp points. See, an oxidizing flame burns with a decided loud roar. The oxidizing flame tends to be hotter than the other two flames. This because the excessive oxygen will cause the temperature to rise to 6,300 degrees Fahrenheit, not heat up much from the thermally inert carbon. When applied to steel, oxidizing flame, especially with the high temperatures, tend to combine with many metals to form hard, brittle, low-strength oxides. This indicates the excess oxygen combined with the steel and burning it, and moreover, the excessive oxygen causes the weld beads in the surrounding area to have a scummy dirt appearance. The flaming will run materials and should be avoided with the except the noted well. Alright, an oxidizing flame is limited with the using the welding. It is not used with welding in steel. The slightly oxidizing flame is helpful with welding. The most copper-based of the metals is zinc-based metals, and the few type of the ferrous metals such as magnesium, steel, and cast iron. A strong oxidizing flame is used with welding of the brass and bronze. Oxidizing the atmosphere in the case creates a base metal that protects the base metal. For example, the welding braze the zinc has a tendency to separate the fume away. The formation of the covering of the copper oxide prevents the zinc from dissipating. And conclude, for the most welding operation, the neutral flame is correct, and the other type of the flames is sometimes needed for special work. Non-ferrous alloys and high carbon steels may require reducing flame. Whistle zinc bearing alloys may need a oxidizing flame for welding purposes. Setting up your oxyacetylene torch. Once beginning with the welding operation, make through the inspection of the area. Ensure that there is no combustible material in the area that can be ignited by the sparks or slag produced by the welding operation. Safety check. Read carefully for the safety consideration. Oxyacetylene cylinders must be securely stored up in the upright position. 3 oxygen torches can produce a large amount of heat. Be aware that any objects that you direct the flame towards will become hot. 4. Always have a suitable fire extinguisher near your work area. Make sure the understanding of the preserved legislative personal safety procedures when carrying out the following tasks. If you are unsure of these, ask your supervisor. Caution: if the cylinder falls over the brakes of the main valve, the cylinder will become a missile and cause extreme damage. 2. Wear a leather apron, similar protective clothing, welding gloves, and using oxyacetylene torch. Always use a proper welding glove. Do not use sunglasses because they do not filter the extreme ultraviolet light as effectively. The plastic used in the sunglass lenses are not to protect the eyes from spark. Use the face mask and valve respirators. 4. Never point the lighted flame toward any other person or any other flammable material. Always lightly acetylene torches within the strike of the cigarette lighter, and then put your hand to the close of the ignition tip. Whenever possible, use the heat shield behind the component that you are heating will prevent nearby objects from becoming hot. 7. After heating a piece of metal, label it as hot with a piece of chalk so that others will not appear to pick it up. Components identification. It is important to learn names of the associated equipment auxiliary related to the oxyacetylene process. Some parts are illustrated below. You have your nozzle blowpipe, non-return valve, flexible hoses, acetylene red, oxygen blue, your acetylene cylinder, maroon, oxygen cylinder, black, flashback arrestor, 2 flashbacks arresters before it goes in the regulator. And these have cylinder contents, outlet pressure gauges, and then from the regulator to the valve to the cylinder. Step-by-step instruction. Check equipment. First, make sure that the gas flow of both the oxygen-acetylene cylinders is turned off tightly. The 2 cylinders are secured with the upright position, usually on a wheeled trolley. Look at the hose pressure of the cylinder pressure gauges at the top of each cylinder. Both gauges on each cylinder should read 0, and both gauges do not read 0. Turn the main cylinder valve on the top of the cylinder clockwise to close it completely. Then you must purge the system for any of the gas. Alright, purging the system. It is recommended that the purge of the gas line becomes the ensure of the non-oxygen acetylene of the line of the vice versa. Ensure that you have adequate ventilation. Purge the system. Make sure that the main cylinder valve is closely tied to pick up the torch handle. Note that it has 2 hoses attached. One hose supplies acetylene, the other oxygen. Turn the oxygen regulator under the gauge. If the gauge is clockwise, open the oxygen valve on the handle. This will purge any of the gas that will still be in the system, and the gauges shall be both dropped back to 0. For about 20 feet hose, open the torch valve for about 5 seconds to allow the oxygen to bleed from the line, acetylene line. For a long hose, consult the welding reference. Repeat the procedure for the acetylene cylinder. Alright, it's installing a torch handle. The torch handle is a connection between the hose and the work tips. It consists of the body of the 2 taps. It is usually both welding and heating. The different attachments connected with the handle to enable the welding, heating, and cutting. Examine the connections. One connection is marked OX and for the oxygen hose. The other is marked AT as in for the acetylene hose. Connect those. The further safety precautions you find with the oxygen connector is right-hand thread and the acetylene connector left-hand thread. Install the correct tip. When the welding tips come inside, they are stamped on with a number. The number 1 is the smallest tip. The relationship between the tip number and the diameter of the orifice may vary within different manufacturers. However, the smaller the number always indicates a smaller diameter. For the approximate relation between the tip number and the required oxygen acetylation pressure, see the table below. Alright, the low pressure injector type, the 0 type size, number 0, 9 psi oxygen, 1 acetylene. For all oxyacetylene type sizes of the tip sizes number, the acetylene psi is 1. Alright, so we'll read this from the line. Tip size number 1, oxygen 9. 2, 10, 3, 10, 4, 11, 5, 12, 6, 14, 7, 16, 8, 19, 10, 21, 12, 25, 3, 30. Equal pressure type pressure torches. Tip number size number 1, oxygen psi acetylene 2, 3 oxygen type size oxygen psi 3 and 3 acetylene 4 type size number 4, oxygen psi 3 acetylene psi 3. Alright, tip size is number 5 and 6, both oxygen PSI and acetylene PSI at 3.5. Tip number 7, the oxygen PSI is at 5, the acetylene PSI is at 5. Tip number 8, the oxygen PSI is at 7, acetylene PSI is at 7. Type size 9, number size 9, oxygen size PSI 9, acetylene PSI 9. Type size number 10, acetylene PSI 12, acetylene PSI 12. The choice of the tip's size depends on the thickness of the metal joint. Larger torch tips shall cause the higher amount of the oxygen fuel flow out of causing a release of more heat. Note that the tips are provided with a number of manufacturers and the size may vary slightly. Oxygen pressure are approximately the same as the acetylene pressure and is balanced with the pressure type torch. Pressure for the specific type of mixing heads and their tips are specified with the manufacturer. Adjusting the pressure for the gas flow. You are now adjusting the gas flow for the heating, looking at the two valves on the torch and the valve next to the oxygen hose control the flow of oxygen from the tip of the close to tightly clockwise. Close it to tightly clockwise. The valve next to the acetylene hose control flow the acetylene to the tip. Close it tightly clockwise. Turn on the gas. Now that you are ready to turn on the torch, you turn the main valve on the top of each cylinder counterclockwise half a turn to open the valve. Then the oxygen tank valve and the backstop valve should be open all the way in order to complete the seal. The acetylene valve should be opened 1/4, 1/3 turn of the turn. Needle on the cylinder pressure gauge will rise to show the pressure in the cylinder. The turn oxygen regulator handle clockwise until the needle of the gauge registers 10 psi. Turn the acetylene regulator hand clockwise until the needle gauge registers 5 psi. This is working pressure for heating. Make sure that the valves are easily accessible in the case of emergency shutdown. Alright, check the area. Before you light the torch, check the area where you're working to make sure that there are no flammable materials, fluids nearby. Workmates should also be clear of the area. The welding flame is not only extremely hot, it produces dangerous ultraviolet rays which damage your eyes. It is absolutely vital that you are wearing the right safety gear, gloves, tinted gloves, and face masks so that put them on and adjust them comfortably. Igniting the torch. Now that you're ready to ignite the torch with a striker tip, the torch must be pointing downwards away from the body and away from the gas cylinders. Hold the striker against the tip of the torch, lighter the cups between the torch, and you flick the striker to create a spark while opening the acetylene valve slightly 1/4 of a turn. This will ignite the gas at the tip of the torch. 2. Once the flame is its open acetylene valve adjusting only until the flame stops smoking. You should get a flame about 8 inches long with a toothy splintering end. Note, now introduce the oxygen into the flame, opening the oxygen valve of the torch, adjusting the two valves, cutting the torch oxygen acetylene until you obtain a short, bright blue flame at the torch tip with no yellow. Adjust the acetylene regulator with approximately 10 psi, turn the screw in to increase the pressure out and to grease it. Adjust the oxy regulator to the same manner to pressure between 40 to 60 psi. 7. Adjust acetylene oxygen valve if necessary to maintain the correct flame. The actual adjustment of the flame depends on the type of the material joined. Flame adjustment, acetylene welder. Mild steel neutral, high carbon steel reducing, gray cast iron neutral, slightly oxidizing, alloy steel neutral, lead neutral, aluminum slightly carbonized, brass slightly oxidized, copper bronze neutrally slightly oxidized, nickel alloy slightly carbonized. Caution: check all the connections before lighting the torch. Never use a match or a butane lighter to light the flame. Always use a flint and steel spark lighter to light the acetylene flame. Before lighting the torch, to be positive the hose and tanks and inflammable material will not be exposed to heat and flame sparks. Never stand directly in front or behind the regulator when opening the cylinder valve. Turn both cylinders immediately when torch flashes back and burn it. Turn both cylinders off immediately when the torch flashbacks and burning on the inside of the first oxygen and then oxygen and then acetylene. Never open both acetylene and oxygen valves before lighting the preheating flame. Always turn the oxygen cylinder valve all the way open. Open the acetylene valve not more than 1 turn, and 1/2 turn is preferred. Adjusting the flame. As you open the oxygen valve, you will see the color of the flame called the pure acetylene flame is yellow. It will change to blue as you add oxygen. Contain the open oxygen until you observe the small, sharp blue cone from the center of the torch flame. This is a neutral flame. You need general heating. The inner cone of the vivid blue for the flare of the burning mixture of the gas issuing from the tip of the is called the working flare. The closure of the end of the inner cone with the surface of the metal being heated with the weld, and that must be effective with the heat of the transfer of the flame of the metal. The flame can be made with soft, harsh, verifying glass flow to a low glass flow. For the giving the tips the size will result in soft, ineffectively flame instead of backfiring to higher glass flow. With the result of the harsh, high velocity flame, the hard handle will blow the glass molten metal from the puddle. The chemical action of flame in the molten pool metal can be altered by changing the ratio of the volume with the oxygen and silicate issuing the tip of the most oxysilicate welding is done with a neutral flame and having the approximately 1-to-1 gas ratio, and oxidizing action can be obtained with increasing oxygen flow. Reducing action will result in increasing silicate flow. Both adjustments are visually valuable aids in welding. Using a torch. The torch tip should be positioned above the metal plate so that the white cone is at a distance of 1.5 to 3 millimeters from the plate. The torch should be held at an angle of 45 degrees to 65 degrees at a horizontal plane. Your filler rod in 30 degrees to 40 degrees, and your torch at 45 to 60 degrees. Torch moved along the joint should either be oscillating a circular for the in the forehand of the welding. The torch made with the direction of the tip that tends to preheat before the white cone. The tip metals in backhand welding. The torch moves backwards. The outer blue flames are directly already welded in the joint. Always allow the joint to be continuously annealed, relieving the welding stress. The welding allows the better penetration as well to form a bigger weld. Backhanding welding is generally used with the thicker materials. When welding rod is used to provide with the filler material, is necessary to hold it at a distance of 10 millimeters from the flame, or 1.5 to 3 millimeters from the surface of the welding material. Pool puddle, or the way the rod's getting preheated when dipped in the puddle when readily getting metalled. Forehand shows the sideways movement, blowpipe, and the movement of the over the wire, movement of the rod slightly above the blowpipe size. Backhand welding, movement of the rod straight in the blowpipe, the direction of the weld going backwards. Oxyacetylene welding can be used in all types of joints and position. Overhead usage requires additional skill and safety guard, but the weld of the various butt and joint edge preparations are shown adjacent to the figure. Thicker plates require more than one pass of the gas torch along with the length of the completing of the joint. The multi-pass welding, the first pass of the root pass is very critical in welding operation. Welding appearances. Welding appearances. Welding gas pressure in accordance with the manufacturer recommendation. The welder is modified the speed of the welding travel to maintain the uniform bead width. Trained welders are taught to keep the bead at the same size at the beginning of the weld. At the end of the weld, the bead gets too hot. The welder increases the speed of the welding travel. If the bead gets too narrow, the weld puddle is lost. The welder should slow down the speed of the travel. Welding in the vertical overhead position typically slower than welding in the flat horizontal positions. The welder must aid the filler or metal molten puddle, but the welder must also keep the filler metal over the flame zone when not adding the puddle to the protective filler with the metal oxidization. Do not let the welding flame burn over the filler metal. The metal will not wet the base metal. Will look like a series of cold dots on the base metal. There's very little strength of the cold weld. When a filler metal is properly added to the molten puddle, the resulting weld will be stronger than the original base. Or you have an uneven movement shown in a good weld and not even heat, oxidizing weld, and proper heating control. Welding appearances. To extinguish the flame and to stop welding, when the welding and the cutting of the operation is finished, close the torch or silicate valve first and then turn off the oxygen valve. Close the oxygen cylinder valve, then release the pressure of the hose regulating the opening oxygen control valve. Release the pressure in the hose regulator by opening the oxygen control valve on the torch. Release the pressure of the oxidizing regulator diaphragm. Turn the regulator to minimum pressure position. Close the oxygen control valve on the torch and repeat the same procedure for purging the silicate. Always weld at least 5 feet from the cylinders. Always place the welding tip so that it points to the side of the torch to which the silicate hose is attached. Do not use any oil or grease on oxygen or silicate connections. Never hammer oxygen or silicate regulators to stuck valves. Beware of high acetylene pressure. Never use acetylene gas when the pressure is greater than 15 pounds per square inch, and the acetylene gas when compressed is not more than 15 pounds per square inch because it's very highly explosive. Do not hold welding or cutting tip to be closer to the work. Never leave the torch burning or go away from it. Never leave the torch valves open. Perfecting the weld. There are several factors that impact the quality of the weld. These factors are the type of the size, the rod size, the flame size, preparation of the metal, torch rod, angle, distance between the torch work, speed, method of torch movement, maintenance of equipment. Tip and rod size. You need to select the proper tip size for the job to get the correct heat for the metal being welded. Some of the general guidelines include tips needed for the selected match size of the filler rod, using the thickness for the gauge being welded. The larger the filler rod, the thicker the metal, the higher the number of the tip to be used. The basic rule of thumb: close with the rod of size of the same thickness as the metal to be welded. The type 3 and 5 steps of the common 3, 5, and 7 common size are usually steel between 1/16 and 1/8 of an inch thick. Flame size: if the puddle is not properly, then it may becomes the incorrect tip size. It may means that you need to adjust your torch valve setting slightly. Remember that you also need the torch setting for the correct flame type of the also neutral. Preparation of the metal. Metal should be free of the rust and grease and oil and paint. Using a grinder or wire brush to remove the rust or the paint. Anything that had oil or grease on it should avoid its potentially toxic flammable when torched. Alright, the angle between the torch flame and the steel helps you to move the welded puddle when you want. Change the angle that you are working with until you find the angle of the work path, usually 45 to 60 degrees distance between the torch and the work. Close the hold of your torch on your work. The more heat is created, the greater the heat. The increase of the depth of the penetration of the weld makes the welding puddle narrower. Speed and method of the torch movement. Slower than speed will make a wider weld with a deeper penetration. The object is to get a flat weld achieved that you may need a slightly back, forth, or overall portion of the torch. A steady, even speed movement is important for the quality of the weld. Maintenance of equipment. The tip of the may come in the plug with the flame of the sideways splatter and go out. You need to make sure that your tips are kept clean for the tip of the cleaner. The tip of the wears been the black and pit as you work with it. Tip cleans the tools as you can fill with the flat tip of the flat. Again, this cleaning of the tip of the cleaners of each of the sides of the tip. Make sure the right size of the cleaner for the tip of the cleaning as the damage before very careful using these cleaners. They can break off the inside of the tip. Advantage of gas welding. Welders considerable control over the rate of the heat and input, the temperature of the welding zone, oxidizing and reducing potential of the welding atmosphere. As a source of heat, the filler metal is separated with the metal deposition can be easily controlled with the heat properly adjusted given the rise of the satisfactory weld. Welding equipment is portable and can be operated in remote places. Besides gas welding, the equipment can be used with the preheating, post-heating, brazing, welding, torch brazing is readily converted with the oxygen cutting. Welded B-side shape and the welded puddle with viscosity are controlled in the welding process because the filler metal is added independently of the welding heat source. Gas welding is ideally suited for the welding of thin sheets and tubes and small diameter pipe. It is also used with repairing welding. The section weld is exempt from the repair work and not economically. Limitations of gas welding. Gas flames take a long time to heat up the metal than an arc. Flame temperature is less than temperature of the arc. The slower speed of the welding compared with electrical arc welding. Heavy sections cannot be joined efficiently. For a heavy section, proper penetration may not be achieved. Refractory metal, tungsten, molybdenum, tantalum, etc. Reactive metals and titanium, zirconium cannot be gas welded. Flux used in filler metals provide fumes that are irritating the eyes and nose, throats, and lungs. More safety recommends than the gas welding. Acetylene, oxygen are expensive gases. Prolonged heating of the joint may result in the large hazardous. They often leads to the increased grain growth and more distortion. In some cases, the loss of corrosion resistance. Alright, for joining materials, the process is used extensively to solder copper and tube in the joint materials which excessively high temperatures, rapid heating, the cooling of the job will produce unwanted harmful charges in the metal. For joining materials in which the cause is extremely high temperature cause the certain elements of metal to escape the atmosphere. For joining most ferrous and non-ferrous metals, carbon steels, alloy steels, cast iron, aluminum, copper, nickel, magnesium, and its alloys, etc. In automotive, aircraft industries, and sheet metal fabrication plants, etc. Section 3, gas cutting.